You are welcome to today's class with Anakwe Christopher GK. You are a chemistry teacher. Today we'll be looking at the topic isomerism. Today, we have isomerism as the topic we will look into. It's expected that by the end of this class, you should be able to explain what isomerism is. Another one is that you should be able to state the types of isomerism. Then you should be able to write isomers of a given compound. State what isomerism is, state the types of isomerism, and write isomers of a given compound. Let's take them one after the other. First of all, what is an isomerism? Isomerism is the phenomenon in which more than one compounds have the same chemical formula, but different chemical structures. Existence of more than one compounds having the same chemical formula, but different chemical structures is what we call isomerism. Chemical compounds that have identical chemical formula, but different properties and arrangements of atoms in the molecules are called isomers. So that two compounds or three compounds that have the same chemical formula, but the arrangement or the structures are different, is what we call isomer. But the phenomenon is called isomerism. Therefore, compounds that exhibit isomerism are known as isomers. Do you get what I said? That the phenomenon in which more than one compound have the same chemical structure, chemical formula, but different chemical structures is what we call isomerism. All right, isomerism can be classified into two basic forms. Two types of isomerism. We have two types of isomerism: structural isomerism and stereoisomerism. In structural isomerism, we have chain isomerism, positional isomerism, functional isomerism, metamerism, tautomerism, and ring chain isomerism. All of them, they're under structural isomerism. Then in stereoisomerism, we have geometric isomerism and optical isomerism. But basically, isomerism is being classified into two types. We have two types: structural isomerism and stereoisomerism. Note this. Then under the two, we have different subtypes on it. Now let's look at them one after the other. What actually is the structural isomerism and what is stereoisomerism? Before we talk about the subtypes, so structural isomerism, the same way it can be classified this way. So structural isomerism is commonly referred as constitutional isomerism. Here, the functional groups and the atoms in the molecule of these isomers are linked in different ways. Now, different types of structural isomerism will be discussed below, as we saw it in the charts. Now, first one, number one, chain isomerism. What do we mean by chain isomerism? Chain isomerism is also known as skeletal isomerism. Has to do with just the chain, the structure, the way the structure is being presented, like the way the skeletal part of it. Skeletal isomerism is what we know is also known as chain isomerism. Now, here, the components of these isomers display differently branched structure. It has to do with the way the chain, the branch, is being placed. Chain means branch in chemistry. So commonly, chain isomers differs in the branching of carbon. Branching of carbon. the way the branch is being placed. Is what we mean by chain isomerism. Something like, let's use pentane as an example. Pentane, which is C5H12 as an example, to illustrate chain isomerism. We will have strong chain, branch chain, and all of that. But look at how it is. We have pentane, the same C5H12. Then we have 2-methyl-butane, the same formula, but it has a methyl in the second carbon atom. Then another one is that, look at this one, is 2,2-dimethyl-propane, the same number, C5H12. So the branching, the structure of how this one is straight chain, the first one pentane, second one branch chain, 2-methyl, and that one branch chain also. So this kind of isomerism is called chain isomerism because of the branching, the way the structure, the branch is being structured. We call it branch chain isomerism because of the branching. So another type is this. That one is this. We have this one as hexane. Another one is this hexane, which is C6H14. Straight chain, we have hexane there. The next one, you can take one of the methyl out and give a branch. We have number 2 here. We have 2-methyl-pentane. It's also an isomer of the pentane of hexane. The next one, we have 3-methyl-pentane. It's an isomer of the first one. The fourth structure, we have 2,3-dimethyl-butane and the 2,2-dimethyl-butane. These are structures, these are isomers of hexane. And that is what we mean by chain isomerism. So this is the most common type of structural isomerism that we often use to draw different structures, isomers of a compound. So these 5 structures are isomers of hexane. All right, let's take a look at another type of structural isomerism. We have positional isomerism. Position. Now, position isomerism has to do with functional group or substituents. Has to do is the position of the functional group or the substituents that are being attached in a substituent in a particular compound, where the functional group is or where the substituent is being positioned. The word position. Maybe the functional group that is on it. Where is the position? It can be changed from one position of the carbon atom or to the other one. Or the substituent, it may be methyl group, it could be ethyl group, it could be chloro, it could be anything. So the position where it's being placed, is that 2, 3, or 1? That is what we mean by position isomerism. So this isomerism involves the attachment of the functional group to different carbon atoms in the carbon chain. Just as I said, changing the position from 1 to 2, from 2 maybe to 3, depending on the structure that is being given to it. So let's use this particular C3H7 Cl as an example and see what we mean by position isomerism. This one, see, the chlorine is being attached in the first carbon atom. It could be chlorine, it could be methyl, it could be anything, it depends. But the functional group or the substituent that is being attached changes position. So here we have chlorine being attached in the first carbon atom. Second one, we have chlorine being attached to the second carbon atom. So the first one is 1-chloropentane, propane. The second one is 2-chloropropane because chlorine is being attached to the second carbon atom. That is all just we mean. All right, that is position isomerism. When we talk about functional isomerism, it's just like saying functional group isomerism. So functional group isomerism is something as functional isomerism. It has to do with just functional group. So as the name suggests, it refers to compounds that have the same chemical formula, but different functional group attached to them. If it is OO, the O have in the structure the same formula, chemical formula, but different functional group is being attached. Let's use C3H6O. as an example. Here we can get more than one functional group structure being gotten from the same chemical compound. The same chemical compound, the same chemical formula, but different structural group. All right, we have propanol, which is in acanal group, and the acanone, which is propanone, acetone. The same chemical formula, but different functional group. Look at the position where the OX and the 2, you see it, or you can present this way. It's the same chemical formula, but different structure, functional group is being found or located on it. The next one has to do with metamerism. However, this one is rare type of isomerism because it's not common in the sense that it's limited to a particular type of a formula that can exhibit it. This type of isomerism arises due to the presence of different alkane chain on each side of the functional group. It is rare, as I said before, and is generally limited to molecules that contain divalent atoms. Atoms that are divalent. We know oxygen is divalent, sulfur is divalent. So when it's being surrounded by a key group, using C4H10O, we can have either ethane, and the methoxypropane from that same chemical formula. The same chemical formula, but different position of the O, where O is being located. All right, we have another one, chain isomerism. All of these are under structural isomerism. Chain, the name, you can see the name chain has to do with isomers that have an open chain structure, whereas the other one has a ring. So one is open, one is ring. The same chemical name, the same chemical formula, but you can write it in an open chain structure and closed chain structure. That is the only thing that is different about it. So we can have propene and a cyclopropane, the same chemical formula, but the structure is different in the sense that one is open structure, one is closed chain, which is ring, cyclo. Example, propene and a cyclopropane. 3 carbon atom and 6 hydrogen atom is on it. We call it ring chain isomerism. All of them, they are isomers. These two, propene and the cyclopropane, they are isomers of that particular formula. So that is it. Stereoisomerism is the second type of isomerism. Two types, structural isomerism and stereoisomerism. Here, this is the type of isomerism that arises in compound having the same chemical formula like the other one, but here, different orientation of the atom belonging to the molecules in 3-dimensional space. The compound that exhibits stereoisomerism are often referred to as stereoisomers. So this phenomenon can be further categorized into two: geometric isomerism and optical isomerism. So here, geometric isomerism is popularly known as cis and trans isomerism. Cis and trans. This isomerism have different spatial arrangement of atoms in 3-dimensional space. We will illustrate this with but2n, which is a acyclic but2n, means that it's not circle. We have this but, has to do with butane, 6 carbon atom. Butane is for alkane, but this one is butene, 6 carbon atom. See how it's been numbered. What actually is different here is this. Look at alkane group. They are in the CH3 is upside, in the 2 side, the other one in the other. So cis is the same, means same. Trans means different. The other one in the right side, we see CH3 is down, one is up. It means trans. We call it trans but2n. While the one that has the same side, we call it cis because they are on the same side, same. So instead of the ordinary butu in, of course, butu in the are. But in order for us to know how the orientation is between the double bonds, C is telling us that the CH3 are on the same side, while the other one is opposite side. It could be another thing being added to it. It could be chlorine, it could be bromine, it could be anything. But C's and the trans enables us to know whether they are on the same side of the double bond or the opposite side based on the orientation. Then optical isomerism is also the same chemical formula but different spatial arrangement of the atom. But this one has to do with mirror image. Mirror image. So these optical isomers are also known as enantiomers. So an enantiomer differ from each other in their optical activity. It's just like when you bring a mirror in front of you or in front of any other thing, you see the way you are, it will present it in a non-superposable image. Just look at this one. We see the compound mirror. What is in the middle? We use mirror, use it to replicate or to represent mirror. In front of the mirror, you have the other image in the other form. Just like yourself, when you are seeing yourself in the mirror, lifting your right hand, it will be looking as you are. Is the left hand you are raising up. That is the mirror image. We call it optical isomerism, which has to do with how the orientation X, how it rotates before a mirror image. All right. So far, we have said that isomerism is a phenomenon in which more than one compounds have the same chemical formula but different chemical structures. Isomers are mainly classified into two. Isomerism is mainly classified into two: structural isomerism and stereoisomerism. These are the basic two, and with that we have now subdivision or classification under them. Thank you. You have really, that is the end of the class, but I would like you to do this particular exercise. Define structural isomerism. This is 2016 number 3 wire question. Then you are also asked to, what is structural isomer? Number 1, structural isomerism is definition. B, what is a structural isomer? 2012 wire question. All right, number 2, write the structural formula of 2,2,4-trimethylbutane. II, ethyl metanoate. 3, trans 2,3-dimethylbutane. 2B, write the structure of the straight chain compound that is isomeric with 2,2,4-trimethylpentane. Write the structure of the straight chain compound that is isomeric with 2,2,3-trimethylpentane. That is WAEC 1988, number 13. With what we have done, just try this. For further discussion or study, we can consult Essential Chemistry, Understanding Chemistry, New School Chemistry, compiled WAEC past questions, and for this further discussion also or any other thing, submission of an assignment, you can WhatsApp me with 080-655-73229, or you can email me at christo116@gmail.com. And that is the end of our class for today. Thank you for listening. May God bless you.